We have learned the logistic regression model and the decision tree model. Both of them can predict the probability for the dependent variable to happen. But which model can give us a better prediction accuracy? In this video, I want to introduce an analysis procedure to everyone so that you can predict which model is more accurate. This is what I plan to do. First, I will separate a data set into a training set and a validation set. As we learned before, this is called a data partitioning. If you want to know the principle of a data partitioning, I listed the lecture video in this video's description section. Please take a look at that video and then come back here. Next, I want to use the training set to build a logistic regression model and a decision tree model. Then I want to use the validation set to test which model has a better prediction accuracy. I want to use an example data set called LoanAnalysis.csv to perform this procedure. You can download this data set in this video's description section. A bank is curious what factors make a customer default a loan. Loan default means the customer doesn't pay back the mortgage on time. In this data set, I have a column called loan default. If a customer doesn't pay back the mortgage on time, I mark 1 for that customer. If a customer pays back the mortgage on time, I mark 0 for that customer. Also, I collected some possible independent variables, such as the balance in each customer's account, each customer's age, if a customer is married, if a customer has a high school diploma, if a customer has a college degree. I want to use these possible independent variables to predict the probability for a customer to default a loan. Let's go to the R software. First, you need to download the data set into your working directory and then import it into the R software. Let's create a variable called loan to hold the data frame. The file name is LoanAnalysis.csv. SEP equals to a comma, header equals to T. Let's take a look at the data structure of loan. Head, parentheses, and then loan. These are the vector names in this data frame. Let's take a look at how many data records do we have in this data frame. Let's use ROC, parentheses, and then type in loan. Totally, we have 43,193 data records. First, let's perform the data partitioning. I want to group the customers who defaulted the loan first. Let's create a variable to hold this group. Let's call this defaulted. And then I want to type in loan, and then a set of square brackets. Between the square brackets, let's type in loan, $, loan default, 2 equal signs equals to 1, and then a comma. By the way, if you want to know how to perform data partitioning, please take a look at another lecture video. I will not repeat the process again here. Let's press enter. This is the group of customers who defaulted the mortgage, right? Let's take a look at how many data records do we have in this group. Arrow, parentheses, defaulted. Totally, we have 782 data records. When we build the training set, we should give half of the 782 records to the training set. And then if we want to build the validation set, we take another half out of the 782 data records. Next, I want to group the customers who didn't default the loan. Let's create a variable to hold it. Let's call this not defaulted. And then I want to type in loan a set of square brackets, and then loan, $, loan default. For this group, I want to type in 2 equal signs, and then after 2 equal signs, type in 0. This means I only want to select the customers who didn't default the loan. Press enter, and then let's use unroll to take a look at the number of data records in this group. Next, let's build the training set. Let's create a variable called LoanTrain.es. We want to draw half of the 782 data records into this group. Default it, and then a set of square brackets, and then type in sample. The purpose of sample is to draw 391 data records out of 782. Don't forget a comma between the ending parentheses and the ending square bracket. Then press enter. This is the customers who defaulted the loan, and we give this group to the training set. And then we want to draw the equal number of data records from the group who didn't default the loan. Let's call this LoanTrain.no. We should use not defaulted for this group. And then square brackets, and then use sample. And then between the 2 ending parentheses, let's type in a comma. For this group, we also need to draw 391 customers who didn't default the loan. So let's type in 391. And then between the ending parentheses and the ending square bracket, let's type in a comma. And then let's combine the LoanTrain.es with the LoanTrain.no. Let's create a variable called LoanTrain. We want to use the rbind function. Press enter. This is the training set. We can repeat the process to build the validation set. Let's create a variable called LoanValue.yes. For this group, we want to draw 391 out of the defaulted group. out of the defaulted group, and then a comma between the ending parentheses and the ending square bracket. This is for the validation set, and this customer defaulted the mortgage. And then let's build the validation set. Let's create a LoanValue.no. And for this group, we want to draw some number of data records out of the customers who pay back the mortgage on time. Not defaulted, and then a set of square brackets. We still use the sample function. Now we need to calculate the number of data records we want to draw from the not defaulted group. We need to do a little calculation. First, we need to calculate the success rate in the original data set. If you use 43,193 to divide 782, you can get that the success rate in the original data set is about 1.8%. For the validation set, in order to form a 1.8% success rate, you want to draw 21,723 data records from the not defaulted group, and then give this 21,723 records to the valid.no. So let's type in 21,723. And then a comma between the ending parentheses and the ending square bracket. Press enter. And then let's create a variable called loan value. We want to use rbind to combine loan value.yes with loan value.no. Press enter. This is the validation set. Now we get the training set and the validation set. We can use the training set to build a logistic regression model and a decision tree model. Let's build the logistic regression model first. Let's create a variable to hold the analysis results. Let's call this loan log. Do you still remember the comment for building a logistic regression model? It is a GLM. First, we need to specify the analysis model, right? We want to use the independent variables to predict the probability for a customer to default a loan. So the model I want to build is a loan default, and then a tilde sign, and then average balance plus age plus entrepreneur plus unemployed plus married plus divorced plus high school plus college. The variable names here must be as same as what they are in the data frame. So you want to be very careful when you type in these vector names. Make sure they are correct. This is the first parameter. And then we want to specify the data source. Data equals to loan train. We want to use the training set. And then the third parameter is family equals to binomial parentheses link equals to two double quotes legit, and then press enter. Looks like I misspelled one vector name, unemployed. It should be unemployed, not unemployed, right? Let's bring back the comments and then change the vector name to unemployed. Press enter. Now we get the logistic regression model. If you want to take a look at the analysis result, you can use a summary. And then type in loan log. I explained how to interpret the logistic regression model analysis results in another lecture video. I will list the lecture video in this video's description section, so I will not repeat here. Next, let's build a decision tree analysis model. Before you use decision tree, you want to start the function apart first. So let's type in library, parentheses, and then apart. Now we can use apart to build the function. The decision tree model function is very similar to a logistic regression model. So let's bring back the logistic regression model we just built, and then modify it to build a decision tree. Let's change the variable name from a loan log to a loan tree, and then remove GLM. Change it to apart. In our part, we need to specify the analysis model, which is the model here, and then we need to specify the source data. It's a long train, right? We don't need the family parameter for a decision tree, so let's remove it. Now we get the decision tree analysis. If you want to see the results, you can use rpart.plot to build a decision tree. I will list the lecture video of decision tree analysis in this video description section as well. Now we have two analysis models. We need to compare which model can give us a better prediction, right? In order to do the comparison, we need to use a new package called ROC, R-O-C. It sounds like the flower, but the full name of ROC package is Random Oversampling Examples. We need to use this package, the ROC function, to compare the accuracy of models. Let's download the ROC function first. Install.packages. And then ROC. Notice that rows are in uppercase. Press enter. And then you can choose any mirror site to download this package. It's ready. Let's start the ROC package. Let's type in library ROC. We need to use two functions under the ROC package. The first function is called predict. We want to use the predict function to apply the validation set to the logistic regression model and the decision tree model we just built respectively, in order to see the predicted probability for a customer to default a mortgage from each model. This is how you use the predict function. Let's apply the validation set to the logistic regression model first. Let's create a variable to hold the analysis. Let's call this log.predict. And then we want to use the predict function. We need to specify two parameters for predict. First, the variable that holds the analysis model, the logistic regression model. It's called a loan log, right? Let's type in loan log. And then a comma. Next, we want to specify a parameter called new data. New data equals to the validation set. Currently, we give the validation set to the variable loan value. So let's type in loan value. This is the predictive model from the logistic regression model. And then we can create another variable. We use the predict to apply the validation set to the decision tree model. Let's call this tree.predict. We also need to specify the two parameters for the predict function. The first one is a long tree, because this variable holds the analysis model. And then a comma. And then new data equals to still loan value. Press enter. This is how we use the predict function to make the prediction. Next, we want to use a function called ROC.curve to compare the prediction accuracy. ROC represents the receiver operating characteristic. I will type in the ROC.curve function first, and then I will explain its meaning. First, let's build the ROC curve for the logistic regression prediction. Let's type in ROC.curve. Parentheses. Between the parentheses, we want to type in loan value and then a $, and then type in loan default and then a comma. The second parameter is the log.predict variable we just built. Log.predict. What this function means is I want to apply the prediction model I just built to predict the loan default rate in the Loan Valley dataset. And then I want to see how accurate the prediction is. Let's press enter. Let's take a look at the ROC curve. In this chart, the x-axis shows the false positive rate. The y-axis shows the true positive rate. Let's talk about them. Let's talk about the true positive rate first. In the validation set, you have some customers who defaulted their mortgage, right? The true positive rate shows the percentage of cases in which your model precisely predicts the customers who defaulted the mortgage. In those cases, if a customer defaulted the mortgage, your model is able to predict that by using the independent variables you choose. So the true positive rate is a good rate, right? Let's talk about the false positive rate. False positive rate shows the percentage of cases in which your model mistakenly predicts the customer who defaulted the mortgage. In those cases, the customer didn't default the mortgage. They pay back the mortgage on time, but your model mistakenly believed that they would be the customers who default the mortgage. So the false positive rate is not good. In the middle of this chart, we have a gray line, as you can see here. What does this line mean? Notice that every point on the gray line has the same true positive rate and a false positive rate. What does this mean? This means if we don't build any analysis model, we just randomly guess who will default the loan. We will have an equal chance of making a correct prediction and a wrong prediction. This is what the gray line in the middle means. Next, we have a black curve in the chart as well. What does this black curve represent? It represents the prediction accuracy from our analysis model, which is the logistic regression model we built. Do we want the black curve to be above the gray line or to be below the gray line? We want the black curve to be above the gray line. Why? If the black curve is above the gray line, that means on each point, it has a higher true positive rate. That means our analysis model can make a better prediction. It's more accurate. So we want the black curve to be above the gray line. What if the black curve is below the gray line? It's not good. Why? Because the gray line represents we randomly guess we'll get an equal chance of making a right prediction and a wrong prediction. If the black curve is below the gray line, that means our analysis model is basically worse than a random guess. That's why if a black curve is below the gray line, you have to pay attention to the accuracy of your model. It's not a very accurate model. Notice that the maximum for the false positive rate is 1. The maximum for the true positive rate is also 1. 1 times 1 equals to 1. This means the total area of this chart is 1. If your model is accurate, the black line should lean towards the top left corner, right? So the larger the area is under the black curve, the more accurate your model is. Fortunately, we don't have to calculate the area under the black curve by hand. The R software will provide the number for us. If you look at the numerical report, you can find the area under the black curve is 0.673 for the logistic regression model. Now we need to calculate the area under the curve for the tree analysis. So let's use the ROC.curve function again. Let's change the log.predict to tree.predict. Now you can see the area under the black curve changed to 0.674. This is the area under the black curve for the decision tree analysis. Which model is more accurate? As I said, the larger the area is under each black curve, the more accurate the model is. So it looks like the decision tree model is more accurate in predicting which customer would default his or her mortgage. Our conclusion is the decision tree analysis model is more accurate in our example.